Hello guys, welcome to our channel. Uh, in this lecture, we'll see what is Syn elimination and anti-elimination. First, we'll see what is anti-elimination. Anti-elimination, anti-elimination is nothing but in the elimination reaction, the transition state which is formed will be anti-periplanar. Anti-periplanar between the uh, proton being abstracted and the leaving group in the leaving group, which we'll see in the uh, which we'll see below. Then first we'll see the key feature of anti-elimination. First, the transition state will be anti-periplanar. Anti-periplanar means the proton which will being abstracted and the leaving group bond should be anti-periplanar, which I'll show here. This is the bond and this is the proton which will be abstracted, and this is the leaving group which may be any this may be ethyl anything, and this may be any group, and these two bonds are anti-periplanar, and anti-periplanar means this the dihedral angle will be 180 degree. Why this anti-periplanar? Because of here this anti-bonding will be towards this. This is the sigma star anti-bonding CX, and this is the bond. When the base will abstract, this proton will abstract, then this bond will towards shift this anti-bonding orbital. That's why this is anti-elimination, and it will be dihedral angle will be 180 degree, and it will be staggered conformation. Staggered conformation means this is the bond, and this is the X bond, and this is the two group, and this is the two group, and this is the proton which will be abstracted, and this is the staggered conformation, and the dihedral angle is 180 degree. Then we'll see what is trans elimination. No, sorry, what is Syn elimination. The elimination reaction in which the transition state is Syn periplanar. The transition state Syn periplanar transition state, and the conformation in the transition state is eclipsed conformation. And Syn elimination possible only with certain rigid molecule. Only it is possible only certain rigid molecule. Here in the Syn elimination, the dihedral angle is 0 degree. Here these two hydrogen C CH bond and CX bond is Syn periplanar. Syn periplanar. And this we can see in the Newman, no, in the source. Now we will see some of the example according to Syn and Anti elimination. Let's take an example here. The ammonium salt, methyl group, and this one is vinyl, and this is the leaving group. And when treated with base like sodium ethoxide, and ethanol, it will give this alkene. pH and H are same side, and methyl and pH are same side. Here you will ask why this is the ammonium salt. It is salt, and you will see in my previous lecture I have already explained about the Syn elimination. When there is this is the quaternium salt, and it will be go through by Syn elimination when we will heat. But in presence of the base, it will always go through by trans elimination. Here already we have used the base NaOH, and it will go through by trans elimination, and it will give this trans alkene as the product. And this one is anti-elimination. Another example we'll take another non-boron system. Here when we'll heat, it will give the product, but here it will give here it is always trans elimination, cis elimination, because this is a rigid system. It cannot it is rigid system, and the elimination cannot take place from the NT, and the elimination takes place for the rigid system always takes place through Syn manner. This bond will go this manner, and this will go this manner, and it will give this non-boron system. This will give the product. This is Syn elimination. Due to the rigid system, it will always go through Syn elimination. Another example we will take, that is this one, pH and phenyl, and this one is methyl, and this one is hydrogen, and this one is the ammonium. And when we will treat it with base like sodium ethoxide in ethanol, it will give and here in the presence of this base, sodium ethoxide base, this in the presence of this base, this ammonium salt, always elimination of this reaction will be takes place in anti-periplanar manner. So here this hydrogen is always opposite to this ammonium group, and it is necessary to take these two groups in anti-periplanar fashion. So we'll rotate these three bonds, we'll constant this bond, and we'll rotate these three bond, also these three bond, because we'll make it anti-periplanar, both of this bond and this bond. So we'll rotate it. How we'll rotate? I am showing you, and here just constant this bond and rotate this bond, because now we'll take this bond to here and this bond to here, like this. And we'll rotate this bond first, then take this is already above the plane, we'll take to the plane, and this bond will go downward, and this phenyl group will be above. When we rotate this bond in this fashion, we will see that this is already below, we'll take it plane, and this bond will go this way, and this phenyl group will be go down. And here now two groups are anti-periplanar, and elimination can takes place easily. And when we treated with base, it will extract this proton, and this will go this way, and this will go this way, and product which will be formed, this is that one is anti product. So we can see it in a Newman projection formula, and we can see it in Newman. We can draw Newman like this. We can draw, and here we will see that I will take this one is NMe3, and here phenyl, and here hydrogen. Yeah, I'll take then NMe to opposite that hydrogen. This will be hydrogen, and enemy opposite hydrogen, hydrogen opposite methyl, and this hydrogen and this methyl are opposite, and hydrogen here, then methyl also here, and phenyl are opposite. See, this is the Newman staggered conformation. Staggered conformation, and base will attack here, and this bond will go away, and this go away. Then another example we'll see. Then another example we'll see that this molecule isopropyl, and this we'll see in the chair conformation. This we will see in the chair conformation. And you will see that here when this will treated with base base like sodium ethoxide, it will give here this bond is anti-periplanar to this bond, also this bond. Here two possible product will be formed when this base will attack. Here the product will form, will be this product will be formed. Sorry, I made a mistake here. This bond will be above, and here it will be like this, and isopropyl, and when this base is attacking here, and this one will go here, and this will go away, and the product which is formed isopropyl, and this is methyl, and this product will be the major product, and the ratio is 75% and 25%. 75% of this product will form because the transition state is more stable in this case.